Hi, Lucy. Hopefully this works again. Alright, first question. First question is about identifying, I guess, what we call an inner and outer function, or like the middle of the present and the wrapping paper. So here, f is the function wrapping around the outside of the function, and g is the inner one. So here, the thing that's doing the wrapping around is this square root. So we could say that f of x is the square root of x, and g of x is simply equal to 3x plus 2. So if we had this here, which is f of g of x, then that would be the g of x going into where we see the x in the f of x. So it's being able to take a compound function, one inside the other, and split it into two separate portions. Here, g of x is the outer one, so it's like the wrapping paper, and that's x cubed, whereas f of x is all that stuff inside, it's the fraction. Alright. Solve algebraically in terms of pi. Alright, I will multiply both sides by root 2. So then we're left with sine x equals root 2 on 2. Now that looks vaguely similar, but root 2 on 2 is really the same as 1 on root 2. So sine x equals 1 on root 2. That occurs when x is equal to 45 degrees or pi on 4. So therefore x is equal to pi on 4. However, there's more than one option here, because remember, in the unit circle, that's our first option. Our second one is over here, which could easily be called, well, it's called 3 pi on 4. And if you ask for more, well, we can go round and round the circle, hitting more and more. It's strange that it doesn't specify. I probably should have made it specify. Alright, let me just grab this one. Alright. If tan equals minus 3 on 2, find sine and cos. Alright, best way to do this is to think about a unit circle, but a scale model of one. So no longer a unit circle, but one that's been scaled up. And tan being minus 3 on 2 is opposite over adjacent. So here, and this portion here, tells us what region we're in. So we're between pi on 2 and pi, so we're out here somewhere. And when we're here, we have about this little triangle. And in this little triangle, we have the opposite as 3 and the adjacent as 2. Here, the adjacent is minus 2, because cos is negative out there, sine is positive. Minus 2 and 3. Now, if we're thinking in terms of Pythagoras, then we want to find the hypotenuse, this length here. And the reason we want to find a hypotenuse is because both sine and cosine have something to do with that hypotenuse. We can use Pythag. So a squared plus b squared equals c squared. Minus 2 squared plus 3 squared equals c squared. 4 plus 9 equals, well, square root of 4 plus 9 is root 13. So this side here is root 13. And then the sine is opposite over hypotenuse. So sine theta equals opposite over hypotenuse, and cosine theta is equal to adjacent over hypotenuse. Now note, they're not actually asking us to solve for theta. They're just asking us to find sine theta. So sine theta is 3 on root 13. We don't need to go any further than that. We can't go any further without a calculator. Alright, the trick is being able to pick which quarter we're in, and then the minus 3 on 2, how that sets up in terms of tan. Alright, evaluate without using a calculator. I assume because you circled it you want help as well. Alright, so first of all we need to know what tan of pi on 3 is, because that's coming in a couple of times. So tan of pi on 3 is root 3. Alright, so tan of pi on 3 we can replace with root 3. So using your working, I can replace that with root 3, and I can replace this with root 3 squared. So that becomes 2 root 3 over 1 minus root 3 squared. Root 3 squared is just 3. 1 minus 3 is minus 2. And those two 2's can cancel out, leaving us with a minus on the bottom, which just leaves us with minus root 3. Alright. This is quite a famous type problem. It's the first time I'm reading it. going through and highlighting. All right. If fsx is x, what is the distance xb? 5 take x. What is the distance ax? All right, ax is a little harder. Ax, we're going to want to use Pythagoras. That'll be the square root of x squared plus 2 squared, because you've got a 2 there and x there. Ax, that line across, is square root of x squared plus 2 squared. Using time equals distance over speed, what is the time taken to travel from a to x? So from a to x, and I assume here he is swimming, okay, because it's across a lake, it's swimming. So bi, swimming at 4 kilometers an hour, time equals distance over speed. So time equals distance, which is the expression we had above, over speed, which is 4. And that's as far as we can go, because we want to find it algebraically. All right, and then VII from x to b. X to b, once again, that time is equal to the distance, 5 take x, over the speed. He's running much more quickly. He's running very quickly. All right. If total time is taken to travel from A to B, show that. Okay, so this path here is this path. And what we've done is that this portion is that portion. This portion is that portion. And now they've just asked us to find what the total time is. And the total time is, well, it's the sum of these two. And note, that's that there. Okay? So I know this problem looks kind of scary and intimidating, but really they're walking you through to get to this stage. And if you're not sure what they've done and if this came up in a test, well, you could just start here if you really had no idea, and you can still get the rest. So, use technology to help sketch the graph. All right, bring it up. Menu 5, get rid of whatever was there before. And now we have to put in this thing. I'll pause it while I do that. All right, entered it in. Drawn. Okay, so use technology to help find the shortest time to reach B. Gsolve minimum. That's the shortest time. So that's when x is equal to 0.408248. Now note, that's not the shortest time, that's just the value for x for which they should aim at. So this here is 0.408. And then to find the time, we would have to take that and sub it into the equation in the place of x. But it's okay, you can do that. How far from x is s in the optimal equation? Oh, well, we just answered that. That's the 0.408. Okay, well, that is it here. Hopefully that helps. Thank you very much.